and hi to all. I remember that last time in our previous class we did cover all our not all some part of our module 3. So last time we can't finish, and per request from all of you, you want the module 3 to be in a video. So here, before I go directly to continue our last class, I'm going to do some recap of what we have covered last time in our module 3. As you remember, last time we did take a look into several things in our module 3. We looked into the basic language. We start with the assembly language, adding and subtracting integer, defining all the important things in our assembly language, and etc. So I hope that you still remember what is assembly language, which is the oldest program language from all language that we have. Normally we heard about like C programming, Java, Python, C++, C Sharp, and etc. All of that is high level language, which is from the basic assembly language. So if you want to learn C programming, Java, Python, it's better for you to know first on the assembly language, because this is the very basic. If you already know and understand assembly language, it's very easy. It's not very easy. It's easy for you to understand like the architecture, how basically programming look like, and so on. So this help you to easily understand others language. And it is the one only native machine language, because our machine language will be using a assembly language. So although you are using your Java scripts, Java, Python, and so on, your computer will be converted to the assembly language first, then your computer will understand. So here we already look last time. Integer constant, what integer constant? Real number constant, character, reserved word, identifier, direction, instruction, operation, commands, register. So all of this we already cover, okay? So don't ask me again, but we just go through several. Like you can see here, we have integer constant. In our integer constant, there how basically the format. So please make sure you look back into your notes and also the video from our previous class. There is also example how basically you can write in terms of the radic. What is the example? Because sometimes the radic can have several representations. You can see here in like your octal here, you can use the Q or also O, which is all it is doesn't matter whether it is a uppercase and also a lowercase. So please go through back, look into several example on the integer constant. After you know your integer constant, you need to know also on the real number constant. You need to know the difference between these two, integer constant and real number constant, because you're going to apply it in your assembly language, in your language, in your programming, etc. So you need to understand. On the term of the format also, please make sure you refer and look back. The example also already been given. Next, we look on the character and string constant. What is character? What is the string constant? Character constant, how it's look like. String constant, how it's look like. And in what purpose? What is the purpose for each of these? Okay. The example embedded codes to be used also are from your characters and constant string constant. When you have that three things, we move to our fourth, which is on the reserved word. If you still remember, this reserved word we cannot use in the identifier. So last time I go for 5 first, then I go back to 4 because I want you to know that this reserved word cannot be used in your identifier. Identifier cannot be same as the assembly reserved word. So go back to your reserved word. What is reserved word? Reserved word, there is several that you need to remember, which is you cannot use for the identifier. This one all we already cover. Under identifier, okay, what is the identifier meanings? So this is the programmer chosen name. So you are the one that choose. You say, I choose this identifier. I'm the one who choose. Because you normally understand the identifier, you want to group something, so you use the identifier, and there is also specification for you to use and also how you're going to name your identifier by using several stated here. And there is also something that you cannot use as identifier, which is avoid use as identifier on the predefined symbol. This is example of the predefined symbols and the symbol that you might use for the identifier. Last class also we did look into the directive. What is directive? How you're going to use and write your directive, which is it is not case sensitive. You can write in any form, but it is known as one, which is dot data, small letter and capital letter is basically similar. And there is also example on how you're going to write your directive and also your instruction. This is directive. And after this we're going to look into direction. So you need to know which one is directive, which one is instruction. Last time we did cover, so take a look back and watch back my video. This one is I just want to recap, right? So instruction here, you have several instructions, like we can divide it into 4, which is labels, instruction mnemonics, operand, and command. So these instruction things, sometimes we can only have 1, 2, or maybe we need to have all. So here at this beside of where is it? I think after this, okay, later on we look. So when you're going to use your identifier and which part is important. If let's say you don't have label, is it okay for your instruction? If you don't have instruction mnemonic, is it okay for instruction or not? So you can see it is optional, it is required, sometimes it is also required, and it is optional. So which one from all these 4 parts you need to remember on the structure? And under your instruction, you're going to separate into several, which is your 4 lah. This is your first thing under label. What is label? You have 2 type of label, which is data labels and also code labels. You need to know 2 of these and which you're going to apply. And second is your instruction mnemonics. Go through and look into I think it can call as a short form also for the instruction. Like MOV is move, add of course is similar. MUL is a multiply. JMP is a jump. So yeah, quite short form, I think so. And you have over here operand. Operand, where you going to apply your operand, and sometimes it's slightly different, and sometimes it's slightly similar to your integer constant. So you need to define which one is your operands, and where you going to apply your operand. So you can see here in this first line, there is no operand. And then second, you have one operand, which is your register. So check back what type of operand you have. Constant is an operand. Constant expression is operand. Register is operand. Memory is one of type of operand. So that's why there is a one operand. Here you have two operand. And last time, if you remember, I did say about we did discuss on this destination and source. Last time normally we said saya dari sini ke sana. Contoh, I'm from Johor. I want to go to Melaka. So normally we will tell our friend that I want to go to Melaka. Instead, for our assembly language or programming, normally it's going to set your destination first. I want to go to Melaka from Johor. So you can see, I want to go to Melaka, which is your destination, from Johor. Instead, last time normally you said to your friend, I want to go to Melaka only. You didn't mention like from where are you from, right? So destination first, your source is after that. Not from Johor to Melaka. Okay? You need to, I want to go to Melaka from Johor. After that, you need to have comment. Sometimes you need, sometimes you not. If you like really master in programming, like very advanced programmer, you look at the sentences or your line or even a comment, you know already what is it. Well, I don't know, maybe it's very master person, but for like our beginner, our like medium higher levels, not higher level. So I think we need to have commands to guide us what is basically for the instruction or the line said for. So it is also needed for someone new into this program. Maybe you want to share to other company, they want to buy your programming. So you need to put your comments so then they can easily understand what is basically happening inside your programming. And in terms of comment, there is two type, which is single line and also multiple or block line. So both you can use. It is depend on you how you're going to apply into your programming. So that is the one that we already covered last time, and we did do some recap on the register last time. So let me go directly now to our register. So what is register? Register are high-speed storage locations directly inside your CPU, which is designed to be accessed at much higher speed rather than your conventional memory. Daripada you punya, if you compare to your hard drive, so register is much more higher and speed, and it's easy for your computer to access. So that is on register. And there is several type of register. Last time in our class also I already discussed what is uh, a what else, EAX, EB, what is B, which is best, accumulator, BX, ECX, count. So you need to know all the type of the register that are available. Last time we did go through all, and you can see here, this is the example. You have AH and also AL, high and low. And what is the length? So you need to remember the length. So it is require you add bits, which is 1 byte. How about AX? AX require you 16 bits. And then you have EAX. EAX is 32 bit. So if you were given with like MOV EAX, so you know that, let's say you have 10H, you need to know that this is occupy your 32 bits. So you can store in terms of 32 bit. If you can see here, you have only 2 digit. You can have more 000 in front just to fill in all your 32 bit storage. So how many that support under AL is 8 bits. AH also support only 8 bit. AX support 16 bit. EAX support 32 bit. It can be also your BX or EBX, as long as you know that if there is E over here in front, it is 32 bits. Only AX or BX or CX is 16 bit. AL and AH is 8 bit. So here also there is a correlation between each other. You can see last time we go through also. And here is the part I think last time we didn't cover. I forgot already, but yeah, it is basically from your lab. Last time we did some on our program table. So after you have gone through your module 3, please do your lab 1, okay? So over here you can see you have the program template. Assembly language program have a, you can read and go through one by one here. But after all, if you still remember when we did our lab 1 last time, which is we go through several on our Visual Studio, there is a template.asm. This is the one that we're going to open. So in our template.asm, this is the basic architecture. Yeah, I remember now we already gone through this. So this is architectures that normally used in your assembly language. And this is an example for you. Write the following program in the text pad or notepad, and then you save as a template.asm. So last time your friend asked on the Irvin 32, is it necessary a must for us to use? So it is one of the library for assembly language. If we don't have this library, so we cannot use the assembly language library. Of course, it's not going to be defined. So example here, you have the adding and subtracting. Register are used to hold the intermediate data, and we call a library subroutines to display the contents of the registers on the screen. Next is the program source code. Let's go through, okay, the red line here. Okay, this one, if you still remember when you play around with your Visual Studio, you can go line by line. This one also we already go through last time in our class. You can see here when we have MOV, this instruction for move. So you're going to move from, this one is what? This is your source. From your source, it's going to move to your destination. So you're going to store this value inside your EAX. And if you still remember, your EAX is 32-bit. When you have there, so you're going to have EAX equal to 10000 hexadecimal. You go for a second line, you can see add, which is addition. You're going to add this value with your EAX currently. So you add with the 4000, add with 1, you're going to have 50000. And now it's updated your new EAX value after you finish with the second line. And for the third line, you're going to see it is a SUB. Sub means that you're going to subtract from the value of your, this one, you're going to subtract 20000 with your EAX. So you're going to subtract, you're going to get 30000 for your last EAX value. And if you still remember, I said that if you want to store and display into your terminals, the output, you need to call dump register, which is to display the register value, the final value here after you finish all the single line. If you didn't use this, then EAX will not display as your output. So okay, right? Because this one we done already. And next here, there is also example. This one, write the following. Okay, this one is similar. Okay, please make sure you try to copy this thing and try to run in your Visual Studio, play around with a value until you understand what is the MOV, what is the add, what is a sub. Okay. Now we're going to move to our defining data. I think I already also covered this one. It's okay. I'm going to go through. Okay, you can see here. Let's directly to go this part. Byte, how many? It's going to be 8-bit, which is, it is unsigned. If you have S in front, then it's going to be signed integer. S stand for sign, B stand for byte. Next you have WORD. ROD means that 16 bits and it is unsigned. For sign, it's going to have S and it still remain the same, which is WORD, which is 16 bits. Then you have D, which is your double word. Double word, of course, your words going to type multiply 2, which is 2 times. And you have sign, double word, and you have another one is far point in protected mode. Q stand for quad, and lastly, last time, T stand for 10 byte, not tera. Okay. Please remember that back what we have learned last time. So, if you were given with this example here, data definition statement, so you please make sure you read first, and you need to know how you're going to store the data. And we're going to store the data in terms of Little Indian order. Let's say, okay, we're going to use this example after this, okay? Let's say here you can see there is one example which is single example. This one is very several example. It said that double word. Please remember back how many double word. So double word you're going to have 16 times 2. Why? Because this is word. Double will be type double times. Okay. So here you have, we're going to do Little Indian order, which is the one that at the back will be putting first. So we will put this in term the order. So first you're going to see your, let's say you are starting at the address. Wait, I use like this. So you have 0 0 0 0 0 0 0 2. Yeah, 2. Okay, I'm going to show at one by one first. Okay, 1, and then I have 0 0 0 2 0 0 0 3. Okay, first of all, normally we will have bit per byte per byte. This is 1 byte. This is 1 byte. This is 1 byte. This is 1 byte. So 1 byte is 8 bits. So you have here, first of all, you're going to have 78, not 78, 78H. Then you have 56. You can see you start at from the back. And then you have 34. You have another one is 1 2. So from here, when you want to take it out, you're going to start from 12. That's why you're going to start write this first, and then second is going to be 34 5 9 5 6 and 7 8 hexadecimal. But when you want to come in, it's going to take first, this, next, next, and next. So this is the meaning by Little Indian order. But in this, you can see it is starting from above. But it is also normally as at the bottom part, because it is 0 0 0 1, 0 0 0 0 0 1, 0 0 2, 0 0 3. Okay, before you can try your exercise 1 and exercise 2, you can just paste it into your Visual Studio and directly get the answer. But you can see here there is example on this. You have first of all count. Okay, I'm going to start with 0 0 above, okay, because I don't want to take it out. So that's why I just follow the addressing. 0 0 1, 0 0 2, 0 0 3, 4, 5, 6. You need to know the word is how many. Look back in terms of your table. Words, it is 16 bit. Double word is 32 bit. So you need to remember all. Mana tadi? Okay, here. So first, you're going to read this. Count is double word. Double word is 32-bit. You're going to have 4. 1, 2, 3, 4. First, you have 4, 5, and then 2, 3, and another one is 0, 1. And if you still remember, this one is 8. This 8 is 16. This 8 is how much? 24. And this is 32. So you need to have all 32 because it said it is a double word. Tengok saya mula dari bawah. Sorry, it's supposedly up here because I start with 0, 0, right? But yeah, already done. So please make sure you know, okay? Normally it's going start from above to down. Okay, because it is not enough, we still need to put something here. So we put 0, 0. And then after that, byte is 1 here only because it's 8-bit. So it will be 6 and 3. Another byte here, which is our M. Then you need to refer to your hexadecimal. Of course, you check your M value. And after that is words. Words, there is only 2 there. You're going to have, but you have several. We have, first of all, we're going to look this first. 2, 5. After that, okay, this one is word. I need to remember. Okay, 2, 5, 0, 0. I continue here, okay. 2, 5, 0, 0, 4, A, 0, 0. And lastly, 9, 9, 0, 0. So this is all the flow. Basically, it's going to be like from up to down. But if you were given the question like this, when you have all of this, you already map it, right? So it will ask you later on in your module 4. Let's say at 0, 0, 0, 6, what is the value? So you need to find this. If you wrongly put, then your answer will be incorrect. Let's say you said, doktor kata dari belakang. So you put here 9, 9. So it's going to be wrong. So you need to know if it is, there is no, kita panggil ni apa? Dalam bahasa Melayu pun ada lupa. Comma. We're going to separate it. So we start with this one. If you have 1, 2, so you pick at back first and then 1, 2 letter. Okay. It's okay. By time we're going to see how basically it should look like. So this is the one that I said. You're going to move from up to down, following your addresses or your offset here. Starting from 0, 0, 0 above. But normally in question is going to give you the initial address. So like this, you have example double word 1, 2, 3, 4, 5, 6, 7, 8 H. So if it is single line, there is no comma, you're going to start with the back 7, 8 first, 5, 6, followed by 3, 4, and lastly your 1, 2. And all together 8, 8, 8, 8, 8. You're going to have berapa? Double word, right? The words is 32 bits. Okay, next. Please try to do this, okay? If you can't know, you can try using your Visual Studio until you understand, or you can just direct ask me. Okay, given the following code, answer the question in hexadecimal. So first, you can see you have CTH byte 34, CTH byte 55. Let's say I put the data in mind, 34 and then 55. Variable 1, which is word 667 7766 9988, and then it's set 0 to your AX. Of course your AX will be empty at that time. Then it has CTH to AH. So you look your CTH, it have 3 4, so you put here 3 4. And BX, what is BX? BX is 0, you clear first. BX val 1. Okay, this is your val starting from your let me check. This one is first is CTH, this is your CTH2, and this is val 1, and this is val 2. So you can see it's said val 1 plus 1. So you have val 1 starting here, and it said plus 1, so it's going to move here. So this is the answer. BX is 66. And lastly, the BX kan. AX here is 34. Saya salah. AH is CTH. CTH is going to be 55. And just now we have the BX value. So defining byte and sign byte. So what is the byte? What is a sign byte? This one also we already look. Okay, now we have another example. Let me show you. First, you have byte. We start at 000. We assume I start at 00. We have A. We put A here. Because we don't know A, unless we were given with the what we can call ASCII table. And then after that, we have byte 0. Byte is 0, so we have 0 here. And byte again 255. This we need to convert to hexadecimal first, because this is decimal. It's going to be FF in hexadecimal. We cannot just direct put because all this is number. You can see the one that you need to put into the value is hexadecimal. Here is hexadecimal, which is in what we can call decimal is going to be 10, hexadecimal is A. And this you're going to convert to your hexadecimal. Please try to do it also in terms of like calculator to check the answer. And for positive 1 to 7, we have convert to the hexadecimal, and this is the answer. And lastly, it said value 6 byte, and then I don't know whether it's empty or it's put this one question mark. So it is supposedly nothing here if it is put nothings. Okay. Multiple initializer. So if you have several, which is I put here the comma there, you're going to start with this, and lastly this one. Normally if it's one single line, you're going to pick the back. But if let's say you have also here the number, you can see, let's say you have 1220, and then you have 2011. So you're going to start with this group first, but you take 20 first and followed by 1 2. And then second, you go for second, you take this 1 1 and then 2 0. So it continues like that. That's why in first single line, you can see here it is byte, which is one table only 8 bits. You have 1 0. So 1 0 going to put here. And then 2 0 you put here. 3 0 you put here. This is your list one. No, you have also another one, which is you have this. You can see this is binary, okay? That's why you need to change to hexadecimal first. Hexadecimal you put here. But you can see here it's directly put here. But you need to know in terms of hexadecimal convert first. Okay. Then it is your list one. Starting from list one, it's moved to list 1 plus 1, list 1 plus 2, list 1 plus 3. And finish already. And it start back with another define, you can see with the list 2, still byte. So you have 4 1, you pick here, and A you list here. Next, our subtopic is on the defining string. So define a string of character, encode them in a single or double quotation mark. So you can see, you can put the double quotation or single quotation. And the most common type of string going to end with the null byte, which is containing 0. Okay, this is example of how you can use your defining string. And then on the DUP operator, if you meet the DUP, what is this? It is a storage for multiple data item using a constant expression as a counter. So you can see by 20 DUP 0. So you're going to duplicate this. So 20 byte all equal to 0. 0 byte unidentified because you don't have anything here. And you have byte 3 DUP COA. So you're going to, how many times you have? You're going to have 20. You duplicate 20 times of 0. You have 20 times of your byte here. You ada 20. You're going to put this one, which is of course you don't have anything inside. You have 3. You duplicate 3 times of your COA. You have COA. You have byte. You have 10. Of course you put 10 first, but this one you need to put into the hexadecimal. And then you duplicate 2 times of your 0. And another one is 20 in decimal. Going to convert it to be your hexadecimal. Next, you have on defining words, single word data. The word define words and the single word defined as a sign word, not single word, as word defined as sign word. So you have example here. You can see this is on the word. How many? Word is 16. Sign word is similar, but it is including the sign, whether it is positive or negative. Okay, all this one is word. In terms of the value, if you want to check down the storage, double word you have 32. So how many box you going to have? In terms of normal table, you will have 1, 2, 3, 4. Assume as it start with the 0, 0, 0. Okay. Assume we start with this. We have, first of all, we're going to have 7, 8. And then 5, 6, and then 3, 4, and another one is 1, 2. So finish on our double word here. For single double word, we have sign double word. So how it is? We need to, you can see if it give you the hexadecimal. Of course, you can directly key in, but you can see this is decimal, so you need to convert to hexadecimal. You're going to get 80000000 hexadecimal. So we will pick this first, second, third, and fourth. We will have another 4 box. This one is 00000080. But you can see this table is like slightly different, but it is basically similar. It start at 0000, 0001, 0002, 0003, 004, 005, 006, and 008, which is similar to us. We have 01, 02, until our 0008. Yeah. And you can see here just now it is a double word. We have our keyword, which is quote word T bytes. And how many of this? For keywords, you're going to have 16 4 bits. So it's going to have 8 quota, I think so. Yes, 8 add box. And for T byte, how many? Which is 10 byte. You have 1 box, 1 byte. So altogether, you're going to have 8. And here is example. Maybe you can try to draw about the table because it's quite long. T byte is another 10. T byte another 10. But you can see you can convert later on to hexadecimal. Constant initializer must be in hexadecimal. That's why you need to convert it first before you write in. And there is another one which is define real number data. You have real 4 defined as 4-bit single precision, real 8-bit double precision, real 10 8-bit byte, not bit, double extended precision. If you still remember last time we play around with the single precision and double precision. And there is like a table standard. You can refer to this. If it is short real, how many digits, long real, how many digits, and extended precision real, how many digits, and the value also included. Adding variables to AddSub program. So you have another new variables you want to put in. So where you going to put? So this is example of your AddSub 2.asm. You can try to copy it also, and write the following program in the text box or notepad and save as AddSub2 and ASM. You can try to run and look into your final answer into your Visual Studio. Please try to do and try to run, okay? And that is on your finding data. And now we're going to move to our very short symbolic constant, very short one only. You can see you have a symbol constant or a symbol definition, which is created by associative and identifier or a symbol with the integer expression or a sum text. Symbol do not reserve storage. This is the keyword that very important for you to know. Equal sign, you can see this is one of the symbols that you need to know, which is equals means that represent the integer expression. See, you have count equal to 5, then you have move al count, so you refer back to here, the identifier you have, you put in your al. And there is another one which is EQU, directive, which is a symbol name with an integer expression or some arbitrary text. Please copy this and try to run. Also look into your output. Then you're going to see the example of the output. Can you get it or not, like this? And please make sure you try like, okay, this one is one single line. It's very easy for you to check, but you can try to run single line, single line, single line, single line. What you're going to see, what is the difference. So this is in terms of summarization. You can go through it, and that is on your module 3. It's very quick one, and I hope after you watch this video you can directly start with your lab 1, okay, because I think we're quite slow. Later I'm going to provide you with the module 4 video, and please make sure you watch also. After that we can go for our lab 2 and also our test 2. Thank you for your watching and stay safe. Bye bye.